The first question is asking us to find, I think I should also put the mark scheme up. I want full concentration, if you don't mind, not chitty-chatty. The first question is asking us to find the probability of A given B. Probability of A given B. A and B are events such that you have the probability of A, you have that of B, you have A union B. So, like most of you did, you found the probability of the intersection first from the addition formula, isn't it? And you're able to use that. But look at the mark scheme. For attempting to substitute into this, you deserve a point. So if you don't show that, you just want to put, probability of A intersection B is equal to 0.3. You're going to lose out on this, you're going to lose out on this, and this says anywhere we see it. So which means I'm going to skip the first two because you are not going to just show your details. We've talked about communication skill. It's very important. You can show more, but never show less. That's some of the problem with some of you. Now, after that, you are supposed to state this also. Of course, you say attempt to substitute into this. But can you just state it? It's in your formula booklet. All you have to do is just copy it out exactly the way it is. Somebody lose the points here for some reason, you know. So that's that about that. So you use that, you substitute, and so your answer could be in decimal or fraction. Both are welcome. Number 2. You see, these are easy stuff. I don't know why somebody will make mistake here. But okay, these things happen. Show that this is equal to that for all n in Z. Integers. Not positive integers only, both positive and negative integer. So use of induction should be out of it because this is not integer plus. And besides, this is direct proof. All you have to do is expand and make sure you get this. Easy stuff. That's why it's just 2 points. Let's see how the mark scheme wants that to be marked. For seeing the attempt to simplify the left-hand side, you are to be given a point. So in particular, we want to see that left-hand side is equal to these two. We want to see that. Then you're going to be given an A1 because we can see that. The attempt, this and this could be on the same line when I mark it. And Miss Krista, can you avoid writing everything on one line? If I mark your paper in an external exam, I won't mark it the same way with somebody that looks like this. It shows that organization skill is not good enough. And this is not the first time I'm talking about this, is it? Miss, why do you keep doing it? You have more than enough papers. Every line, 8 lines, everything on one line. Now, if you notice, I write feedback. I write a note back to you, right? So imagine if you wrote everything on one line. So how do I write a note? I go this way? Can you please? All right, AG means already given. So we are not going to mark because you got this one. This is already given. We are interested in the process. This last time is already given, so it's not a mark. They're just going to see AG, means already given. Ends. What does ends mean? Quickly, please. We need to be fast, please. No time. Using A. But it says ends or otherwise. It means, okay, if you have any other alternative, it's allowed. But using A, why would anyone want to find an alternative anyways? This is talking about the sum of squares of 2 consecutive odd. Are these not consecutive odd numbers? So it's just a continuation. Shows that that sum is even. All you have to do is connect this back to this. And if these are, all you have to say is, okay, let two consecutive numbers be 2n minus 1 and 2n plus 1. Their sum is going to be, the sum of their squares is going to be that, which is equal to this using A. Understand? Let's see what the mark scheme asks us to see. Method 1. Recognizing this. Did you see that? Well, if the candidate recognizes that, give 1 for the reasoning. Okay? And you use the A part. Once you write this one, the fact that the candidate factorized this, mark A1. But that's not the end. So if you do this and you stop, it means you don't get this last point. A valid reason, e.g., which is divisible by 2. That note we always write. Okay? R1. If you write a conclusion, the conclusion is already given. It's not to say you shouldn't write it, but you will see AG. Oh, so therefore, based on all this wonderful stuff that I've done, it means that the sum of any 2 consecutive odd numbers is going to be even. That is already given in the question, so that's why it is AG. Understand? Another method. Maybe you don't want to use those ones. That's why it says ends or otherwise. So you decide to choose your own n and n plus 2, which are also consecutive even numbers, provided your n is even. Okay? Odd. Recognizing that n and n plus 2 are 2 consecutive odd numbers. So if I want to mark this, I need you to first tell me, let n be an odd number, because n could have been an even number. Am I making sense? Let n be an odd number. Then n plus 2 will be the next consecutive odd number. Then you will get the first one. Understand? Then when you had the sum of their squares, this square plus this square, when you do this, you don't even know to say then n is of the form 2k plus 1. No. You can just go ahead this way. And you can see that you can factorize your 2 out again. So someone might decide to do this way. If you decide to say let n be an odd number, then n can be written in the form n is equal to 2k plus 1. That's fine. Then the next one will be 2k plus 3. That's fine. Let's see. Here. Let n be an odd number. Let n be 2k plus 1, right? Let n be an odd number, so n will be in this form. The next consecutive one will be n plus 2. So that will have been what? 2k plus 3. So if you square this, so n squared, n plus 2 squared, will actually be 2k plus 1 squared, 2k plus 3 squared. Is that not? And this will have given you 4k squared plus 4k plus 1. This will have given you 4k squared plus 12k plus 9. Even. So 2 can be factorized from the result. So either way is fine. As long as everything you do is logical, you communicated well, you'll be given your point. That's why it says ends or otherwise. Number 3. This is integration. I'm quite surprised that as cheap as this is, some of us missed it. I think we talked about it yesterday. When you are having integration by substitution, you don't have business with the square root. I hope you are listening. We don't have business with the square root. The variable is that term under the square root. When do you know this is an integration by substitution? Who can tell me why you will know this is an integration by substitution? Because, wait, we have f prime of x is equal to 8x divided by the square root of 2x squared plus 1. It means my f of x will be the integral of 8x divided by the square root of 2x squared plus 1 dx. How do you know this is integration by substitution? Why is it not integration by part, partial fraction, and all the other, idea? Why is this substitution? How do you know? Can you take that back off so I can see Callista and please sit up properly?
You can eliminate x from the numerator if you differentiate 2x squared.
If you differentiate this, you get a function of x, and x is here waiting for you to be eliminated. That's how you know. That's the only thing. The derivative of that guy hiding under the power or root is related to what you have at the top. If this is x squared, and this can produce multiple of x squared, not a term in x squared, x, and x, no. X squared with a number. We don't have any problem with number. If you can produce ordinary x squared, the x squared here is waiting to get it cancelled. If your derivative here can cancel the variable here, then that is substitution. So you start by saying let u be 2x squared plus 1. This implies that this is the only time you write on the same line. This implies that the u dx is equal to 4x squared, which implies that dx is actually du divided by 4x squared. You can see x, wait, 4x, my bad. You can see x, we cancel this x. That's how you know. If this happens to be sine, then there should be a cos waiting for you here. If this is square root of tan plus 1, there should be a sec square or multiple of sec square waiting for you here. That's how you know it's a substitution. So from here, f of x actually is going to be f of u now. Okay? Or better still, no, let's call it f of x, because we're going to transform it back anyway. So from here, f of x, are we capturing this, miss? From here, f of x is equal to the integral 8x square root of u du divided by 4x. Then your x is gone. And then you have 2 integral. Somebody forgot to put this 2. Was that you, Calista? Somebody forgot, and everything was perfect. But the mark scheme is nice, I'll show you. So you have 1 over square root of u du. That's the idea. So that at the end of the day, the variable is with respect to the same variable. So we shouldn't see any x. That is why we must manipulate this such that this x need to be gone. So this is integral to integral u to power negative half. I think somebody made a mistake with this power. I'm not sure. Consequently, your f of x is 2 u to power plus half and another plus half, then plus c. So this is now going to be 2, so everything becomes 4 u to power half plus c. So this is square root. 4 square root of u plus c. Then you put it back. 4 square root of, what's your u? 2x squared plus 1 plus c. So this is where you substitute 0, 5. So f of 0 is equal to 4 square root of 2 times 0 squared plus 1 plus c. F of 0 is 5. So this is 4 root 1 plus c. So this is going to be 4. So c is equal to 1. Therefore, your original function f of x is going to be 4 square root of 2x squared plus 1 plus 1. Look at how the mark scheme wants this graded. If I see an attempt to integrate m1, Miss Krista, did you see? Huh? Ha. Once you transform into this point, we give you a1. Now, how you proceed from here, there are 2 ways. It's either we see this, we give you a1, or at this step, we give you a1. Okay? Then your correct substitution into their integrated function. So if you got it wrong, but you substituted correctly, I give you this m1, but you won't get the last point. So for example, somebody wrote only the square root of u. Who's that? Clarissa, right? Is it you? Somebody wrote only square root of u. But of course, they got a different c. And that c was put back here. This will be wrong. But because if this had not been wrong, this substitution would have been perfect. That m1 will be given. That's what the maxim says. It says, correct substitution into their. So, their means the wrong one. Whatever it is. Understand? So, 5 points. Easy stuff, guys. Easy stuff. This we were talking about in class. Some people did something very smart, which I mentioned before. The first thing they did was to, let's work smart. The first thing they did was to get the graph of f of x all squared. That's the first thing they did. How do you get the graph of f of x squared? You know that your x in the intercept, the x-intercept is when y is equal to 0, right? If y is equal to 0, it means f of x is equal to 0. So that point will never change when you square it. It's more or less, oh, when I substitute 3, maybe f of 3 is equal to 0. It means when I do square of it, it's still going to be 0 squared, which is equal to 0. So which means this point will never change. Understand? This point also will never change. Invariant points, that's what we call them. Is that not? Then also, this, whatever this is, the square will be that. So some people did this first. So they went by saying, okay, it turns here, it's going to be rubbish. Something like this. Because remember, whatever this is, it's going to be squared, right? So it's going to be on the other side. A square function does not go to the negative. So now, if you look at the asymptote, it approaches -1. So this will approach 1. It's more or less having, maybe you put it in a rational form. So you have some fraction, px, maybe p over qx, for example, plus 1, something like this, then followed by your -1. So that when x becomes large, this part becomes 0. And then you have only this. Am I making sense? Are you getting my point? So if you still square the function, all this will contain the x again. Is that not? And this will end up giving you -1 times -1, which is +1. So which means for the square function, the asymptote will be here. So as it turns, it goes like that. Nakita, understand? As it turns, it goes like that. So now that we know this, all we have to do is make it jump up. Because the question is about f of x squared plus 1. So that's the translation. So you move it one step forward. So instead of being on the point 1, 0, when it jumps up, it's going to be on the point what? Speak louder. 1, 1. Here, instead of being on the point -1, 0, when it jumps up, it's going to come here now. This is going to jump to 5. Understand? So that gives us something like this. This will be on 5. I hope it's the same scale. Okay, it's not the same scale. So when it jumps up, this will be on 5. This will be here. So it's going to be like this. Okay? And the asymptote that was 1 will become what? 2. So I expect to see the asymptote y is equal to 2. I expect it to turn here and never touches the asymptote. I expect it to turn here, something like this. I expect it to come down, turn here, something like this. That is the graph of your square function. Understand? Let's see how the mark scheme wants us to judge. No y must be below. I think I have one person who draw something below, and I'm like, come on, this is a square function, cannot be below. So that one point is lost. Oh, uh-oh. We are done with you. Okay, no y must be below. If I see the asymptote, another 1 point. If this 2 local minima points, you get to deserve another 1. If your turning point is seen at the top, the maximum one at the top, get another 1 point. If you take note of the fact that this is a curve, and you're not just, oh, it's a sketch anyway, you draw a line or something not so nice, you don't deserve the last one. But this last point is for smooth curve and smooth stationary point. 5 points. Next one. This we've talked about, but we'll talk about it again since we're recording so that in case you want to remember what we talked about, Miss V, maybe I use this board and write and erase it all the time. Is that okay? So get the question and we'll put the solution on it. Mr. Chen, can you help us try to move this up a little bit? Be mindful of the power. Be mindful of the cable. Now, that cable, if you move it if you're not careful with the movement, you might just disconnect it. Maybe we just do, that's good. Yeah, that's not bad, it's okay. Perfect, thank you, sir. Now, go. Press something there. Okay, we still have time, we can do this. We have this, we've talked about this before. G composed with I love technology. I don't even know what the function is. What is G? So G composed with f of x is equal to one thing most of you fail to write. I saw G bracket f of x. I expect to see G bracket, what is that f of x?
X plus 3 all over 4.
X
Plus 3 all over 4.
x plus 3 over 4. I expect to see this. So you have your, let's write it here. F of x equals x plus 3 over 4. What is your G of x?
8x plus 5.
8x plus 5? Good. So, applying that, 8 into brackets, right? X plus 3 over 4 plus 5. Some of you multiply 8 in first. You don't have to do that. You cancel. You cancel, you get 2 brackets, right? X plus 3 plus 5. So you get your 2x plus 6 plus 5. And that's how you get your 2x plus 11. Okay? Then, for the second part, this is A. For B, as I said before, half of the class, if not more than half, the first thing you did was to find G dot F, G composed with F inverse of X. You don't have to do that. We've talked about that. And I wrote a comment for everybody, I'm sure. So all you have to say is since G composed with F inverse of A is equal to 4, then if you want to isolate A, this goes to the other side but in inverse form, right? So it's going to be G composed with F acting on 4. Everybody understand this? Brandy? And you? Okay, great. So, and because this is already a result you have obtained, so you just substitute. So A will be equal to 2 brackets 4 plus 11. And that's how you get your 19. You don't have to waste time finding inverse function. Okay? Let's look at the mark scheme. So messy. Don't worry, I'll push it away. I'll push it back again. Let's look at what the mark scheme says. Not you. See? Even the mark scheme shows that. Can you see? Oh, sorry. Show this, show this. So attempt to form composition. If you can see that, okay, oh, this is what you are trying to do, composition. Then if it's correct. So if it is not correct, you get your M1, but you don't get this A1. If it is correct, you get your A1. Final result is AG because it's already given. Okay? And here, this is just substitution, you see? Nothing like inverse function. Oh, if I see that you substituted 4 and it's correct, and you get that. So attempt to substitute, you get M1. If your substitution makes sense, you get A1. Final result, you get A1. Okay? Easy stuff. Now, let's look at the next one. We want to show that, just put it here. I want to show that because it's not graph anymore, so maybe no need. So move it around all the time. Miss V, over here. Okay, we have shown that log to base 9 cos 2x plus 2 is equal to log to base 3 cos 2x plus 2. Some of you try to be tricky here, try to be smart. It's okay to be smart, but you don't get everything, especially if your smartness is caught. A lot of people know the final answer, so they are just trying to work towards it. That's not how to solve a math question. That's not how you get your point or get a good grade. Left hand side, log cos 2x plus 2 base 9. You can see where you are going has base 3. That tells you something automatically. What is that? You need to change the base. Look at your result. Your result says base 3. You have base 9. So even if you don't know anything, the first thing that should come to your mind is what? Oh, I need to change this base. So you change the base. Log over log. That's how you change base, isn't it? To the new base 3. Why this is 9, this is going to be cos 2x plus 2. And this is where you get your 2. So you get log to base 3 cos 2x plus 2 divided by, I just write 2 to save time. And this is what you write as half log divided by 2 means half. Somebody wrote it at the in front times half. No, put it at the back. And then you apply the law of logarithm. To power half. And this is how it becomes the square root that you're looking for. Not by trying to play on my intelligence. Nice try, by the way, for those of you that try to play on my intelligence. What some people did is this. And the next thing I saw from these two is half. So I wonder how. You already know this is what will give you the answer. You just jump from here to here. You have not done anything. I'm not sure if I gave 1 point or not. If I did, then you are lucky. If I did not, then of course I don't have to. To me, you don't know what to do. You're just trying to, be smart, which is good. Sometimes it's pays. So if you are clueless, at least be smart. But try not to be clueless, especially for easy stuff like this. Especially for paper 1, guys. It's paper 1. If you cannot maximize the level of question in paper 1, then what do you say in paper 2? Understand? Let alone paper 3. I think paper 3 is not that tough. It's a guided investigation, I think. Understand? So the next thing we are asked to do is to solve this equation against ends or otherwise. Ends or otherwise. So this is wrong. The equation log to base 3 2 sine x is equal to log to base 9 cos 2x plus 2 for 0 less than x less than pi over 2. So which means our angle is between 0 and 90 degrees. But this question is in radian. Somebody gave an answer in degree. Okay, maybe not in this question. I think it's another question entirely. Your angle is in radian. Somebody was writing 30 degrees. In some other question, I think. Okay, this is what you want to solve. Ends means use the previous result. How can you use previous result? This has been converted into base 3 as well. So this is simply log to base 3, 2 sine x, another log to base 3, this time around, square root of cos 2x plus 2. That's the first thing. And because the logarithm on both sides is now on the same base, then you can equate the number. And you can remove the square root by squaring both sides, isn't it? So 4 sine squared x equals to cos 2x plus 2. If you want to solve this trig equation, can you solve with sine and cos together appearing?